All right, welcome back everyone. Let me see how many problems I can do before my battery decides to quit on me. All right, so I've kind of showed you some of these problems. I know that in order to do well on these, we need to do many. So I will try to do as many as I can, just showing you. So let me give
me a word problem real quick. A 10 ohm, 15 ohm, and 5 ohm resistor are connected in series across a 90 volt battery. So that is the problem. Let us find a VIRP, or let's create a VIRP chart regarding that. Okay, so that is voltage, current, resistance, and then power finally. So power should be the last thing that we solve. I think I did it the other way. It doesn't matter what orientation you use. I think I put these here. It doesn't matter. So let's just do R1, R2, R3, and then R total. I can say total or battery. Okay, so let's make this chart. There we go. I know, I'm the worst at making charts, but it is what it is. So let's move forward. Okay, so since it's in series, let's draw it out. Okay, I didn't give you
a diagram. Let's draw it out. Okay, 90 volts right here, just a 90 volt battery, plus and minus, and then they're in series, so it shouldn't be too bad. So if it's in series, I can just do one root, and then right here, so this will be, so I told you the first one was 10, so this will be volts, amps, ohms, and then watts. So R1 we said was 10, this is 15, and this is 5. Oh no, whoops. Resistance 10, 15, 5. Okay, I will try to find a way to figure that out. So what is the total? So since this is in series, okay, I can just add them all up, no problem. So this together should be 30, and then of course this right here is 90. So these are our knowns, right? Not this one, but these three and this right here. So in regards to that, let us figure out what we can find. And forgetting about this, let's see, just do like a Sudoku map. All right, what are we missing? What is the easiest thing to solve? Well, right here I have 2 right here and 1 missing right here, so that means I can find it. Whereas right here I have 1 known, 2 unknowns. So let's figure this out. So knowing that V equals IR, I can figure out my current is equal to V divided by R. So 90, so I total equals 90 volts divided by 30 ohms. So that equals 3 amps. Like I said, I'm trying to do this quickly, so I might make a few mistakes. So 3 amps. Now, this is what a lot of people might do incorrectly. They might do, and here, I'll write this in red so you know it's wrong. They'll be like, oh, I have 3 resistors. I know that it will be the same, the current will be the same running through them. So just like the resistance adds up, this will be 1, 1, and 1, because 1 plus 1 plus 1 equals 3. Incorrect. In series, the current coming out of the battery is actually the current that flows through every resistor. So this 3, you can actually just copy and paste it above here. Just drag it up. So the actual current is 3 amps per every resistor if it's in series. So then now I have 2 knowns, and then I can figure out my unknown. Sorry again for getting that incorrect, but 3 times 10, V equals IR, so this times this, 30, this equals 45, and this equals 15. And if you add up 30 plus this, 30 plus 60, 90. Do you see that? So we know this works. And the other way to check your work, to make sure this works, is by doing this in multiple ways. Remember, P equals I times V, and then V equals IR, V equals IR. So you could do it this way, or if you want, you can plug in IR for this, so P equals I squared times R. Or you could do it another way. You can plug in I, so this would be V squared over R. So you can do it this way. So the way to check your answer is by making sure if you plug all these in correctly that they will come out to the exact same answer. Okay, so if we did this, 3 times 30, excuse me, power should be I times V. So 3 times 90 should be 270. Okay, and this is in watts, don't forget. Let's check this way, okay? So P is I squared, so 3 squared times R should be 270. Do you see that? 270. And then this way, 90 squared divided by R, I'm not going to do that in my head, but I'm guessing it would be 270. And then if you do all of these, even for power, it doesn't matter if they're in series or in parallel, the power of every single resistor should add up to the total. That's something that's quite interesting. So let's just do the first two real quick. This should be 90. Here, let me write in the original. This should be 90. If I do this, if I do I squared times R, 3 squared times 10, 90 as well, okay? So do you kind of see that? 90. And then, oh, that should be blue, that's okay. Let's see, V equals IR, so this times this, 90, 135. So this should be 135. Now this I squared, so 9 times 15, I'm guessing it will be 135. Actually, yeah, 150 minus 15, 135. And then, so then we'll have I times this, so this would be 45. 45 right here. And then if I do I squared, 9 times 5, oh, look at that, 45. So do you see how they're the same answer? That's how I can check to know if my answers are correct. Also, these should add up. So this will equal 180 plus 90, 270. That's how I can check my work. All right, that was a fairly simple one. Let's do another one. Okay, so again, I think the part where most people get messed up is that they see this as 3 and they'll try to divide that amongst these 3, but no, this is the same throughout. So remember, in series, the current is the same through every resistor. Cool? All right, let's do another one real quick.
Okay, this is a little more challenging. So I have VIRP. Okay. So we know for this, or we can just call it 1, it doesn't matter. We know that this is 60, this is 90, and this is some unknown. We don't know what it is. But something else that we do know is that the ammeter and the current for the circuit is 0.67, or 2/3, and then my total voltage is going to be 130. So these are our knowns. I'll just leave it like that. So let me draw it. I'll draw it a different way. Okay, so this is 60 ohms, 90 ohms, and then, I don't know, ohms. But this is 130. Okay,
so 1 second. Okay, so remember, in series, the voltage of the resistors has to add up to 130, and the series will be the same. Okay, so we have to carry this forward. What some people have done is they scratched this and they said 0.67, 0.67, 0.67, and they added all that up, and then they got 2 right here. Remember, for current, you don't do that. This you can just drag up here, because in series, the current coming through the battery or the total current is the same everywhere. So 0.67, 0.67. Okay, So how do I figure out, again, let's use two knowns to find the one unknown. So in this situation, I can find this, and then I can also find that. So let's do that. For R1, V1 equals I1, R1. So you can just plug that in. So 2/3 times 60, what is that? Okay, 2/3 amps times 60 ohms. 120 divided by 3 volts, which is 40 volts. So this is going to be 40. Okay, you can do the same here. Also, let's do that. So V2 will equal 2/3 times that. Here. $180, this should be 60. 60. Okay, also, just like Sudoku, oh look, I have all of these, this, and this, so I can figure that out. What do you think this should be? If this is added together is 100, what do I need to add to 100 to get to 130? Well, this would be 30. Do you see that? Also, to find the total, the other way to do that, and then I can use this to find R, or the other way to do this is, what is my total resistance of the whole circuit? Well, this times this, 130 times 2/3, that'd be 260 divided by 3. Okay, so what this should be then is 130 divided by this, and if I do that, this would actually be 195. Okay, so now this is the method that I would actually prefer you to do, because if you did this, you know the equivalent resistance is the sum of these. So R1 plus R2 plus R3. And I know what these are. And I know what this is, so I can find that. So R3, let me write that over here. R3 is going to equal to R equivalent minus R1 plus R2. Put that in parentheses. So let's write that out. R3 is going to be equal to the equivalent, which is 195 ohms, minus the sum of these two, so 150 ohms. Do you see that? Okay, then I should get 45 ohms. So R3 equals 45 ohms. And let's see if that's true. If I do 45 times 2/3, 30. And good, that seems to be correct. Now, let us do the power. 1 second. And there's two ways to do that. Again, I would say if you check this twice, then and they're all the same, then you know you did this correctly. So the way that I like to do that again is power equals IV, my professor IV, or you can do either of these two equations. P equals I squared times R, or P equals V squared over R. Either way works. Use this one initially, and to make sure it's correct, I would probably do another one just to check and be sure. I know it's more work, but this way you know for certain you got it right. And remember, it doesn't matter if this is in series or not, or they could all be in parallel. It doesn't matter. The power of all of the resistors should equal the power coming from the battery in any situation. There are no special cases like there are for series or parallel where the voltage and current may change depending on the configuration. Nuh-uh. Power, they will all equal, the sum will equal the power from the battery. Okay, let's do this real quick. Okay, I just did the calculations real quick. So let me just do it without writing it down. To get my power here, if I did current times this, so 40 times 2/3, I would actually get 26.66. If I did, let's just say this way, 40 squared divided by 60, I would actually get the same answer. Let's do this. P equals IV times this, 60 times 2/3. Well, if you did that, that would be 40. Also, if you did 60 squared divided by 90, you would actually get 40 as well. Don't forget, this is volts, amps, ohms, and this is watts. So if you did 30 times this, that would be 20. And if you did 30 squared divided by this, it would be 20 as well. Now, also the last test is to add all of these up. So if these add up together, it should equal to this times this. And if you do this times this and you add all of these up, guess what? It is the same thing. And then forever. So that is the best way to check your answers. Let me move on to parallel real quick. So now you've seen series. Remember, this is the same, the current is the same if it is in series. That's one thing you need to remember.